Hi, I'm Dr. Alexander NGENZI from University of Rwanda College of Science and Technology, Department of Computer and Software Engineering.
Okay, we are going to continue with which is said to be Forden sequence. What is Forden sequence? It is a sequence. Remember, previously we were talking about the time reversal, the way how signals can be depending to x of n. This is a clockwise direction, but also it can be a reversal way, which is counterclockwise or anticlockwise direction. So in this case, for the Forden sequence, it's going to be from the point, from the center of the circle, and just showing the arrows where it is going to, the direction, where the direction is taking to. So this case is going to be clearer than the previous one, which is a time reversal. So maybe we will have to show their graphical presentation. Remember, the other circular presentation is trying to show the graphical method that we said. Now it's going to be the Forden from the point of origin. Okay, now let's say Forden sequence. So as I said, the Forden sequence is going to, suppose if we have a signal, so in this case, for example, it is going to show you directly the x of n, where it is heading. For example, if we have the x of 1, x of 1 of n, in this case, it will show you the direction from where it is going. Now, in this case, it's going counterclockwise. So it's going to be, the values are going to change. For example, if this point is x of 1 is equal to n, okay, x of 1 is 1, then x of 2, for example, depending to the other sequence, given to the other values from the beginning. You remember where we had x of 1 of n being 2 into 1, 2, 1. So this is what we are talking about. So the x of 2 in this case, x2 of 2 in this case is going to be 2. x1 of 3. These are the position that I'm putting in bracket. Then this is point, and this point is going to be x1 of 0 is going to be which is equal to 2. Also is going to be x of 2 at 2, which is equal to 2 in this case. So when you reverse, for example, you just put another element here, for example, showing the x of 2, also of n, also going this direction, and having, for example, x of, we are now bringing in the x of 2, the other one where we said the x of 2 of n, which is equal to 1, 2, 3, 4. In this case, at point 3, and the x of 2 at 0 is equal to 1 in this case, and also the other one, x of 2, in this case, x of 2 is equal to 1. No, x of 1 is equal to 2. Yeah. So it will remain, so this is 2. This is the other, the same as 2. Also here, 1, 4 in this case. So it is going to be folded. So it's going to meet together so that it will show the same direction. But when it comes, for example, the other way around, for example,
these ones you can see they are taking the same direction. But also you can have at x is equal to 3, I mean using the other signal, the other way around, in this case it's going to be x of 2, x2 of 2 is going to be 3 in this case. And remember, this is going to be x of 2, for example, changing the negative, I mean the anti-clockwise, the clockwise direction. So it's going to look at this side. It's going to be folded on that side. And then x of 2 is going to be x2 of 1 is going to be 2, and x of 2 at 0 is also going to be 1 in this case. And then x of 2 at 3, these are the points for example, so it doesn't make any difference. So it's going to be 1, 2, 3, 4. So I have never changed the values of x2 here, but the other one is folded. It becomes almost the same, so the signal have never changed. So this negative is changing the signal direction at this particular point, and then it goes the other way around. So having all these ones, suppose if we are going to solve this one using the graphical method as we mentioned from the beginning, then it's going to be, for example, as we said from the beginning, x of 3 of n is going to be the convolution of x1 of n, convolution of x of 1 of n with convoluted with x of 2. And remember, the thing remains the same. It's going to be summation of from m is equal to 0 of n minus 1. Then you put our signals of x2 of big M, I mean our m, then x of 1, then n minus 1, n minus m in this case, n minus m in this case. So this is what we discussed even before, the way how they are going to be converted. So it will follow the same. So this is what we call graphical method. So we are showing some of the graphs, the diagrams, the way how it is designed in a convolution way. So remember to put this one because it's very important during the convolution. So you can see this direction doesn't show any convolution, but when you bring this side, you are making convolution using this graphical method.
So you can have different values, or it's not only this one. You can have some other examples having so many values.
But when using this summation after, remember it's like convolution sum. You will add some of the values. For example, taking the signal. For example, here if you say x of 3, in this case you will have some numbers. For example, at any particular point, this one, you can get some points. For example, 2 plus 4 plus the other values around, and you get, for example, you get 2 plus 6 plus 2, like that. Then you get 14, for example, at x is equal to 1. Then the other one also after getting, for example, m signal converted, for example, at m signal, in this case x of 3 of m can have some other values. Then you can, depending to how you have twisted, then you find, like, for example, it is becoming like 2 at x3 of m, becoming depending to how you obtain the values in this case. So it is in that way. So it depends to how you have supplied in your system. Remember, if you are using this one, you are adding, but also at the same time, there is where you find n minus m, from where, for example, you try to reduce. You are reducing n times, for example, from n minus 1 instead. So you can see it is a combination of the other one that we said. At additional, you reduce and multiply, and the multiplication, but this one is a sum. So you take two signals, this one, then you add the other one, then for example, in this case, you can get, for example, 16 as the total summation of these numbers. So this is what we can say about the graphical method. So okay, so you can see all of these ones, the graphical presentation and the other one using DFT and so on, and matrix format. They follow the same the same steps. For example, if you put any equation or any formula without applying this convolution, then you will have failed to do a circular convolution. It can be commutative, or where you find different operations following one another. So you can have as many operations that you may have. You may have as many operations as you wish. So it will depend how many terms or the values that you want. So that is like a reminder or the remark. So we have seen some of different types of different types of the way how you can obtain the convolution sum. But also here we have the folding, as I said. We have the time reversal, but also maybe for the next 30 minutes we are going to discuss about the shifting folding sequence, multiplying using the shifting or the summing values of the folding sequence.
To summarize what we have seen before, and the next 30 minutes period, we are going to summarize what you have seen about the folding sequences. We said we use the folding, that is the reversal and so on and so forth. We also have to do shifting. We can also do what we call shifting, where we put some values from shifting by left or right. So you can do that by using folding, shifting, but in the end we have seen that you have also to use what we call multiplying the two signals using the convolution sum, and also in the end you have to sum up what the results. So those are the main 4 steps doing this convolution, circular convolution, using the other methods of graphical, DFT, and matrix format. So the next portion is going to highlight a few of those things and having some examples in one by one of what we have mentioned.